So the next problem that we have to see is 12th problem in thermodynamics book back. See here they have given enthalpies of formation of carbon dioxide. What do you mean by enthalpy of formation of carbon dioxide? When carbon burns in oxygen, it produces carbon dioxide. Formation for this, in this reaction, 1 mole of carbon dioxide is formed. Enthalpy of formation means energy released during the formation of 1 mole of the product. So enthalpy of formation of carbon dioxide, see we call this as formation enthalpy because here in this reaction, if you see this, carbon dioxide is formed from its elements in their natural state. What is the natural state of carbon? Solid. Oxygen gas. So enthalpy of formation, how do we define it? It is defined as the energy change that is happening during the formation of 1 mole of any compound from its elements in their standard states, isn't it? So here the energy released during the formation of carbon, see during the formation of carbon dioxide, it happens to be a combustion reaction. So energy is released. How much energy is released? The values are given in the continuously they are given. So just you take it in the proper order. Formation of carbon monoxide is first given. C plus O2, half mole. See 1 mole of carbon, when it burns incompletely, insufficient amount of oxygen, we get carbon monoxide. When it gets burnt completely, we get carbon dioxide, isn't it? So incomplete combustion, that is 1 mole of carbon just burns with half mole of oxygen means we get carbon monoxide. And for this, del H is how much? Minus 110 kilojoules per mole. For the formation of carbon dioxide, it is minus 393 kilojoules per mole. Okay. Next, what they have given, formation of N2O. N2O, how is it formed? N2 plus O2 gives N2O. What ratio? Here again, half mole. See, we have to first balance the equation according to our requirement. So for this, del H is given as plus 81. See, this is these two are exothermic reactions. That's why energy is released. This is endothermic reaction. So energy is absorbed. And the last one, N2O4. N2 plus O2 gives N2O4. For this, the del H is 9.7 kilojoules per mole. Got it? Now, what are they asking? Calculate the del H for the given reaction. Which reaction is given? See, we have to balance this equation also. N2, here also 2, here also 2 balanced. Here you have to put 2O2. Then only you will get N2O2. So the reaction, look at the reaction, N2O4 gas plus 3CO, 1:3 mole ratio they are reacting. Both are gases and we produce N2O gas plus 3CO2 gas. Got it? See here in all these, the enthalpy change accompanying a reaction can be easily calculated using the formula del H for any reaction is heat of formation of products minus heat of formation of reactants. Okay. So what is the heat of formation? See, the enthalpy change given in this, the data given here can all be taken as heat of formation of, see, this one is the heat of formation of carbon dioxide because in this reaction carbon dioxide is formed. This one is the heat of formation of carbon monoxide because in this reaction carbon monoxide is formed. This is the heat of formation of N2O. This is the heat of formation of N2O4. So what you do, see in this reaction you see which are all the products. Which are all the products? N2O is one product. Okay, so this is heat of formation of one of the products. So wherever there is product, I'll put subscript P. For reactant, let me put subscript R. Okay, so N2O and CO2 are products. But the problem here is in this equation, 3 moles of carbon dioxide is formed. But here the enthalpy change we have only for 1 mole. So what you should do? When you multiply this equation, entire equation by 3, see this is the enthalpy change accompanying formation of 1 mole of kilojoules per mole only we have written. No, for 1 mole of carbon dioxide formation, this much energy is released. But in this equation, we have 3 moles. So what you should do, del H value, I should multiply by 3. Because for the formation of 3 moles of carbon dioxide, I need to multiply this value by 3. Okay, but N2O I can keep it as it is because here also 1 mole, in this equation also I have only 1 mole. Okay, so heat of formation, instead of heat of formation of products, what can I write now? Take the enthalpy of formation of N2O. What value is it? 81. Okay, so first let us write down the enthalpy of formation of products. Add them together, and from that we should subtract the enthalpy of formation of reactants. So 81 plus 3 moles of carbon dioxide, what is it? Minus 393 into 3. Got it? So this entire thing you put it in a square bracket because we have to simplify this, and from the simplified value we have to subtract the simplified value for the product side. So in the product side, what do we have? N2O for formation enthalpy is how much? 9.7. Got it? So here for CO, what is it? Here again, 3 moles of CO is getting involved in the reactant side. So here I have only for 1 mole. So what I should do? Multiply. Yes.
Ma'am, I have a doubt, ma'am.
Yes.
In the target equation, N2O4 is in the left-hand side, ma'am. So should we not reverse that N2O4 in that main equation they have given to put minus 9.7 kilojoules?
Yeah, that's what. That is taken care of. See, I have used it in the form of a formula here. So the formula takes care of the reversal of sign. Okay, here I have put minus common. Got it? So instead of using Hess law also we can use. What can we use? N2O4 here. If you want to use in the form of Hess law, you can write N2O. Wherever N2O is there, N2O is on the right side here, right? And CO2 is on the right side here. So we have to add first equation and third equation and subtract second equation and fourth equation, isn't it? That's what we are doing here. You understand? So when we use Hess law, when we add all these equations according to the requirement, whichever reactant is on the reactant, whichever substance is on the reactant side, you try to keep the equation as it is, and whichever is on the product side, if it is already in the original equation, if it is on the reactant side, we will just reverse the sign and use. So here, that's what I am doing in terms of, see, for this reaction, we are calculating del H, right? So I am using it in the form of formula. So heat of formation of products. What are the products here? These two products. These two are the products, right? So for wherever they are formed, those del H values I am adding up. Minus what are all the reactants, for them the del H value I am subtracting. Okay. So you can do it using Hess law also. There also you'll get the same answer. So this is another type of formula that I can use for this calculation. Some students find this formula a little bit easier. That's why I'm introducing to you this formula also. Okay. So this N2O4, where is N2O4? 1 mole of N2O4 is formed. No, the del H value directly I'm writing. And for carbon dioxide, 3 moles are getting formed. So 3 into minus 390. Oh, sorry. Carbon monoxide. 3 moles of carbon monoxide, what is the value? Minus 110. Now first what you do? You simplify this one. What is this value? Have you calculated? Minus 393 into 3 plus 81.
1093. 1098.
Yes.
Which one is 10? Simplified value,
Yes, ma'am.
minus 1093, is it?
Yes, ma'am.
No, how will it come 1093? 81, no. What is 393 into 3? 927. 1179 minus 81 only, no, ma'am. One 1098, won't it come?
1098.
98, okay. Minus 1098. Minus, what about this? Minus 330 plus 9.7. So this, here again you have to subtract. How much is it? 0.39. 329.3 will come, isn't it?
320.3 minus 3.
I'm sorry. 320.3. Yes. 320.3. This,
Yes,
see, within the square bracket, the value is negative, isn't it? Minus of minus will become plus. Am I correct? So simplify this and tell me the answer. What is del H? Kilojoules per mole will be the answer. 1098 minus 320.3. How much is it? 0.7. 777.7. Am I correct? Minus 777.7 kilojoules per mole. Very clear? Chandrasekhar, are you able to understand?
Yes, ma'am.
Just substitute in this equation. The equation இருக்கு இல்லையா? Products என்ன வருதோ அதோட heat of formation அப்படியே எழுதிக்கோ. First on the left side you write. Okay. Product N2O just 1 mole is there. So write the value as it is. And CO2 3 moles are there. So the given value for CO2 del H you multiply by 3 and substitute here. Minus heat of formation of product reactants, what are all there? N2O4. N2O4 1 mole, so write the value as it is. For CO, you multiply by 3 and write it. And then simplify, that's it. You'll get the answer. So use this formula. And see, for a reaction, entire reaction, if you are asked to calculate enthalpy change, use this formula. Enthalpy change in the reaction is equal to heat of formation of all the products put together minus heat of formation of all the reactants. That will give you the final answer. Got it? Clear? Copy down fast.